All right, picture this. You're starving, you nuke some leftovers, and 2 minutes later, ding, perfectly heated food. Like magic, right?
Right.
But it's not magic. It's a tiny computer, an embedded system,
Yeah.
calling the shots.
Yeah.
And at the heart of that, the CTU. That's what we're diving into
Yeah.
today using this awesome source that breaks it all down. So I always thought of CPUs like the brain of a computer. But what's actually going on in there?
It is a great analogy. Think about our brains, right? We get info from our senses, we process it, we decide what to do. A CPU is similar. It's constantly fetching instructions, decoding them, and then executing them, like, all the time. Moving your mouse, even streaming this right now, it's
So
wild.
it's not just one thing, it's this fetch, decode, execute cycle I keep seeing.
Exactly. That's the CPU's heartbeat. It's always going through those three phases.
Okay, so break it down for me. What's actually happening in each of those?
So fetch is like going to the library. The CPU grabs the next instruction from memory. Decode is like reading those instructions. The CPU figures out what it has to actually do, and then execute is where the magic happens doing it, whether it's a calculation, moving data, whatever the instruction was.
So find it, understand it, do it, and over billions of times per second.
Yes.
That's incredible. But how? What's actually in a CPU that makes it work?
Okay, so inside, there are these specialized units for each part of the cycle. Think of it like a super organized kitchen, right?
Okay.
The control unit, or CU, that's the head chef, and make sure everything's in order. Then you got the MAR and MDR, those are the line cooks.
Okay.
MAR, or memory address register, it knows where everything is in the computer's memory, like a librarian.
Okay.
Fetches the address of that next instruction, right? And then the MDR, the memory data register, actually goes and grabs the data from that address and brings it back to the CPU to use.
Wow. Teamwork makes the dream work.
Uh-huh.
But this is all happening crazy fast, right? We got to be talking clock speed here.
Yeah, you got it. Clock speed's basically how many cycles the CPU can do each second, measured in gigahertz or billions of cycles per second. It's a big part of how fast a computer feels, but it's not the whole picture.
There's more. So it's not just as simple as bigger number equals faster computer.
Exactly. Think of it like this. A chef with super speed chopping skills is great, right?
Right.
But if they got to run across the kitchen every time for an ingredient, it slows down.
Makes sense.
That's where cache comes in. It's like the chef's workstation. It's small, super fast memory, keeps frequently used stuff close. More cache, less the CPU has to go to that slower main memory. Speeds things up.
Love the analogy. And I'm guessing more chefs is better too, right? Like a whole team instead of just one.
Exactly. That's cores. CPUs these days can have multiple cores. It's like multiple chefs, each with their own station. More cores means more tasks at once.
Okay, so clock speed, cache, cores, it all matters. But CPUs aren't just in our laptops, right?
Right.
Like we said, my microwave has something going on.
That's the world of embedded systems. Specialized computer systems made for a specific job, hidden inside all sorts of devices.
They are everywhere. Washing machines, medical devices, traffic lights, even my smart thermostat. It's kind of wild when you think about it.
And the CPU they use depends on the task, right? A simple one, like a microwave, might use a low-power microcontroller. A self-driving car that needs something way more intense. There's different CPU architectures too, like ARM and x86. ARM is known for being energy efficient, like in phones, while x86, which is in many laptops and desktops, has more power.
So whether it's making coffee or landing a plane, it all comes down to fetch, decode, execute. This crazy, complex tech symphony, and it's a tiny orchestra of ones and zeros making it happen.
It really is. Makes you appreciate how much goes into even the little things. Like when you think about it, it changes how you see tech.
It does. So next time your toast is popping or your car's figuring out directions, that's the CPU. A world of power and complexity right there.
Right at your fingertips.
This has been awesome.
It does.
Until next time, keep on learning.